Good morning, ladies and gentlemen. It's a very ambitious challenge to give an introduction to Industry 4.0. On the one hand, we know this term. It was coined in the German economy. It's a major economy in the world focused on industry. On the other hand, this notion has been interpreted in a number of ways. And when we talk about Industry 4.0, what is crucial about Industry 4.0 is to answer the question how to use the automation and data processing in industry. Recently, I had the opportunity to visit a super modern factory in Poland. I talked to automation specialists. It was a very insightful conversation because the automation specialist engineer who knows very well the production system and knows all the relationships there, he said he knows it's possible to collect data, that the data are collected by sensors, but how about the use of those data? He's not sure as an automation engineer how to use the data, and this is the crux of the problem. How to use the data does the future lie in data collection, or perhaps in more appropriate use and interpretation of the data, trend analysis, prediction of the future, all that we want to deal in industry to increase its competitiveness. Now, it should be said that we've seen a sea change in this area in industry itself as well as among consumers. The market is increasingly open to ideas about using rather than owning, about not developing solutions in R&D centers, but about co-developing, co-creating solutions that closely match consumers' needs. So this circle might look a little complicated. It encompasses Internet of Things, cloud, big data. So analysis of huge volumes of data, artificial intelligence. But all of these elements are supposed to better meet the needs of users and consumers. So this is at the core of the whole revolution, because the competitiveness that for a long time has been focused on cost, for competitiveness has been shifting to other areas. So still about cost optimization, but now it's increasingly about the efficient use of resources, about finding resources, including human resources. It's increasingly more difficult to get workers, employees. It's increasingly difficult to ensure the right education for them. Now, technology has completely changed business. Now, on the example of music and music carriers, perhaps it's a rather trivial example, but it shows how change has been accelerating. So the time intervals between the various inventions decrease between the old ways of using music and new ways of doing so. Now, this has had a tremendous impact on business models in the market. In the past, here in Warsaw, everybody went to a store on Zbawiciela Square, Planet Music, and that store is a thing of the past now. But now Spotify, its beauty of it is not that music is available and for free, but the beauty of the solution is that based on known pieces of music, you can develop some new offerings, new solutions. So there is a new possibilities of interaction between technology and humans, and this is a fundamental change. This is what these 4.0 solutions have brought about. In terms of Polish businesses and businesses around the world and the readiness for 4.0 solutions, large technological companies are spending between 11 and 15% of their budgets on research and development. In Poland, however, some businesses do not have R&D units at all. Now, these are extreme examples, small and medium-sized companies in Poland compared to Google or Microsoft or huge technological companies where those outlays may reach up to 15%. So this change that is ongoing right now causes a situation where the companies that have not spent any money on R&D, or they did to a very limited extent just to improve existing products, I think their existence on the market is threatened. It is said that the leaders, let's say, of the world say you go to bed as a production company, and in the morning you wake up as the owner or manager of a company that deals in data analytics, functioning in an entirely different environment. So in this way, the emphasis has shifted in terms of competition. It's not only about products, but also about product development, many uses, new uses for products, a life cycle of products, how long the life cycle is, and how the product may be adjusted to consumers' needs. In small and medium-sized enterprises, it is mostly owners or managers who decide how to tackle the challenges associated with R&D. I would like to show you two fundamental elements of Industry 4.0. I believe that in the course of our discussion we will build on this, but industrial Internet of Things, it's about distributed communication between sensors, devices, and elements of a network, and this communication enables the implementation of a variety of solutions based on cutting-edge technologies. Now, industrial Internet of Things has been increasingly used with billions of devices connected to the Internet. So now the issue is about the effects of that connectivity, how we can decrease the let's say, operational costs. Now, in terms of maintenance, it's a decrease of repairs 12%, maintenance 30%, and in terms of downtime, a reduction of 70%. So the cost effects, the increase in efficiency has been quite extraordinary. Now, we have developed the idea of predictive maintenance thanks to modern technologies. We can now predict potential breakdowns, defects, and to remove the defects or prevent them in real time, and to do that in the shortest possible time to prevent downtime. I'd like to mention one solution that has been implemented at Bayern Munich Stadium, their turf. I hope that there are other football fans here in the room. Now, the turf that is obviously the critical point of a football club, this is something where the Internet of Things can play a critical role, as they have special sensors in the turf that measure insulation, humidity, other processes occurring in the grass, all these data are sent to cloud, they are analyzed, also the weather is analyzed, changing air humidity, temperature, and as a result of that analysis, recommendations are provided about how to insulate and water the turf. And the whole process, that analytical process, the cycle is every minute. So the status of the turf is measured every minute. Another core technology that is very promising from the point of view of the industry is digital twinning. Probably by 2021, about 50% of the industrial facilities will be using digital twins. Now, NASA was a forerunner. In Apollo 13, they first used a digital twin, and that digital twin became highly reputed, especially in the automotive industry. It's a dynamic model that makes it possible to analyze the reaction of devices and materials to external factors online in real time. The costs of product tests are much lower. Products are tested virtually to a large extent. You don't need to perform tests in real life. Now, digital twins make it possible to avoid design errors. So it's a great, powerful tool for the industry, and a predicted increase in efficiency is about 10%. Now, going back to what I mentioned at the beginning, key competences. So who is to make sure that all these elements of 4.0 industry will be implemented? That in Poland, for example, we have a plethora of programs. You've heard about them perhaps. They're aimed at bringing the Polish industry to a high level of development. But the competences have been evolving as well. Traditionally, it was thought that technological competences are of the essence, that they are the factor of change. So if we have good engineers, we will successfully transition to Industry 4.0. Obviously, master engineers, that's obviously critical, but interpersonal competences, social competences are also very important. This is a transformational exercise, so what you need is skills that will allow us to build good teams, to communicate appropriately, to promote Industry 4.0 elements. So from an engineer that mostly dealt with technological issues, well, those engineers are now expected to exhibit soft competences, which are now believed to be critical in terms of carrying out the transformation. So how can we do this? I guess that's a very important element. How can we build the knowledge? How we can retain it in the company? We as Siemens prepared a report on smart industry. We asked small and medium-sized enterprises how ready they were for Industry 4.0, for the change. No, the answer is pretty straightforward and unsurprising. The first study that we carried out, enterprises stated that their readiness level is very low due to cost factors. So whether it is profitable, whether it's you can get your money back. Well, it's not an issue anymore. Everybody must invest, but just at the right time and in the right things. So those decisions on investment, they are made primarily by company owners, CEOs. Small and medium-sized companies are mostly private companies, so the private owners decide about it, and they are pretty risk averse, because if they invested in their company many years ago and now somebody tells them that they have to invest in something else, their resistance is very natural. But nevertheless, we can see a great role for education and raising awareness about transformation, how we must not treat spending on new technologies as mere costs. We need to build new business models. You need economic knowledge, also social knowledge to build teams and to make sure they function well within the company, because investment should not be a task for technological engineers, but the whole organization should be transformed. Now you can see the possibilities for knowledge retention. First of all, you need to generate the knowledge. So you need to start with bringing cutting-edge technologies to the company. You need to have experts that would be able to implement them. You must select the right technology for your company. Obviously, expectations of engineers have been evolving. If you do not represent technological companies, probably your companies carry out programs that are designed to bring the world of science with the world of business, to recognize what competences, skills are needed in industry at this stage of education. Academia is increasingly open to the voice of business and industry, and indeed engineers are expected to lead their companies through digital transformation to make sure that products are increasingly innovative and that the processes will be innovative, because cutting-edge technologies change not only products but also they affect the career pathways, they affect production processes, and they affect what is most important for a company at a given point in time. At the end, I'd like to encourage you to analyze smart industry reports. You can find plenty of information there about the readiness for Industry 4.0 on the part of Polish enterprises. Now, we have seen a change in paradigm from perceiving insufficient capital as the main block to change. This shifts to inadequate competence. Increasingly, enterprises, entrepreneurs claim that insufficient competences hinder development. So entrepreneurs also perceive investment in a different way, and they understand that investment is about deciding the future of their companies. Thank you very much for your attention.